Today we're gonna do a problem of a simple energy balance problem, and what we want to find is what is the mass flow rate from tank 1 to tank 2. Now the conditions are that this tank 1 is closed and it's under 30,000 pascal gauge pressure, and tank 2 is open to the atmosphere. Now we're neglecting the friction in the pipe, and then we're also neglecting the pipe angle. This is a simple problem. In a more elaborate problem, you have to take those things into account. And we're saying that the pipe diameter is 0.1 meters. All right. So then we need to do we need to state the energy balance, the energy equation, which is that Q minus work is equal to the mass flow rate times the change in pressure over rho density plus 1/2 v squared, this is the kinetic energy, plus g, gravity, times delta z, this is the height difference for account to the potential energy, plus friction. And this, when we solve, our goal is to initially solve for this V. But we know that there's no heat in the system or no work, and we're neglecting friction, so we're left with this. And because we have 0 in this side, then we can also we can divide both sides by m dot, and we get we just get this equation. So what we get is, we get something like this. So we get negative v squared equals to 2 times delta p rho plus g delta z. Now we just gotta do this. So for our pressure, we know we do the difference, so we do tank 2 minus tank 1, and then what we get is now tank 2 is open to the atmosphere, so we know that the gauge pressure here is 0, so we get 0 pascal minus 30,000 0 pascal over the density of water, because we stated that is water what is inside the tank, which is 1,000 kilograms per cubic meter. This plus g, which is 9.81 meters per second square, that's acceleration due to gravity, times the change in height, which in this case would be 4 meters minus 10 meters. And all of this will give us negative velocity. And so once we, now for what are the units of this? In here we get meters times meters over second square. So we're gonna get meters per meters square per second square. And here for the pascal, this is important. This can be tricky to do for if this is the first time you're doing it. So you know a pascal is equal to kilograms meters second square, and then you're dividing it by kilograms per cubic meter, which is just multiplying it by the reciprocal, which is equal to cubic meters over kilograms. The kilograms go away and this meter goes away, and then here you get 2, so you end up with just meter squared per second square, and this is the same unit as down here, so you obviously are doing it right up to this point because you got that part right. Now when we get to this point, so we get for negative v squared, we get negative 88, oops, we get negative 88.86 meters squared second square. Now when we pass the negative to this side, divide by negative 1 here and divide by negative 1 here, and take the square root, we get that the velocity is equal to 9.42 meters per second. Now you see, and those are the correct units for the velocity, and units are very important in this problem. So, and you should always write them, because if you get something that is not meters per second square, you know that you did something wrong. So always follow through with the units when you're doing these problems. And so this is our first step to our problem. And so now, well, let's just do it here, the second part of our problem. Just very simple. Now we're given the pipe diameter. So in order to find the mass flow rate, we need to find the cross-sectional area of the pipe. And so we know that area is equal to pi times diameter square over 4. And this is going to be equal to pi 0.1 meters square over 4. And this will give us a very tiny number, which is 0.00785 meters square. Okay, so now in order to find the mass flow rate, or m dot, we just simply multiply our velocity, which is 9.42 meters per second, times our cross-sectional area, which is 0.0785 meters square, and this should give us 0.074 cubic meters per second. And you know that at least up to this point the units are right, because you got the correct, actually here I only calculated up to this point in my problem because I forgot a step. Here you get how many cubic, you get volumetric flow rate. However, if you want to find the mass flow rate, all you have to do now is multiply this number times the density, which is kilograms per cubic meter, and the meters cancel, and then you end up with a mass flow rate of just simply this number, 1, 2, 3 kilograms per second. And this is your mass flow rate, and this is how you know that you got the correct answer, or at least very close. You might have messed up in one of the calculations, but at least you know that up to this point your units are right, so you must have been very close to the answer if it's not the correct answer. But these problems get very long and very, very tedious, so you might make small calculation errors and you gotta go back and find them. But if you know that you didn't get something, that you got something here like kilograms square over second, or kilogram over second square, or something along those lines, then you know that you definitely did something very wrong, because those are not the correct units. So my recommendation for this energy balance problems is please carry the units throughout the whole problem. Thank you very much. Have a good day.